Hello my friends, welcome again to my video channel. Today we will start a new project, Yaesu FT-301D, one of the first fully transistorized shortwave transceivers, I think from the late 70s or early 80s. 100 watt output, all shortwave bands, the so-called old ones, the WARC bands are not included, but CB 11 meter is included. Nice feature, but it doesn't work, of course. The owner brought it to me. There were some modifications, or are some modifications inside. So let's see. A first optical check on the front. The plastic cover is loose, okay, no problem. The S-meter is fully deflected to the right side. The RF gain is set to maximum. When I increase the AF gain, I hear a very weak noise. CW, AM. That is the rear side, the PA brake or booster as it's called in the manual. Okay, there's the output of the driver, it's the input, out is in. Sounds logic, it's in the manual stated in the output of the PA is to the input. Input means band pass or low pass filter, connection of the power supply, antenna. It looks rather good for its age. So let's have a look inside. And here we have the first surprise. There is a unit, this is the original AM unit, PB1556, it's the AM unit, which is plugged in here. And this is an additional unit located here. This is the FM unit, type PB1707B. And this is the FM unit from the FT. Luckily there's a documentation. It's the PB1707B, and this is from the FT-902 DM. It's one of the later transceivers, and the FT-902 has an FM option obviously, and this is the board which is also installed. Now I'm a little bit surprised or baffled. AM and FM, how does it work? What is FM, what is AM switch? Because we have only one mode switch for AM. Is some of the settings maybe FSK app used for FM? Could be. I have to study the documentation because there are a lot of papers, additionally a lot of handwritten notes. So I will find out what's going on there, but you see some modifications, not so nice, but in general, obviously the receiver has a problem with the S-meter. So I will focus first on this topic. Now let's focus first on the problem with the AGC and the S-meter. We have here the IF section, IF unit, and here we have the point where the rectified DC from the IF stage is fed via this connection, and additionally the second diode, which is a cathode connected, transfers the voltage over this potentiometer, which is the RF gain on the front. Here we have a zoom in into the IF unit. This is a connection of the RF gain, what we have seen. Here we have a resistor, 24K, this pot has I think 5K. So we have a voltage divider depending upon the setting of the RF gain. When the RF gain is fully grounding this point, here we have 0 volt, no voltage is added to this line where we have the rectified output from the IF amplifier. This stage, here is a diode biased, and then we get here a voltage, positive voltage, and this drives the AGC and meter amplifier. The output on the emitter, it's low ohmic, 33 ohm grounded, goes to the S-meter. And here we have the output of the AGC line, which goes to the RF unit for gain control. This is the collector resistor. The resistor is 1K and we have here 33K, so the main voltage drop is here, and this is only a little bit which is controlled by this resistor to have an S-meter indication. The RF gain makes it possible to add here some voltage, so the transistors get more conductive and we have more S-meter deflection, and in our case we have full deflection of this S-meter. The RF unit obviously gets no voltage because the gain is 0 or very low. We have no output, we cannot hear anything in receive mode. So maybe the problem is here, so we will first check the voltage at pin 12 for RF unit. And also this point here, this connection of the RF gain pot. I took out the RF unit, it is plugged. I wanted just to check the connection points, and I saw this modification. 2 red wires. And these 2 red wires, when I follow them, they are connected here, this point, and they go to the pot which is called RF gain. 1 wire is interrupted, as we see. The other 2 are connected to this point where they should not be. And on the other side I see there's a resistor which is R410 below this capacitor. This resistor R410, which is here, is missing. Only the capacitor C407 is there. And instead of the resistor R410, we have the pot for the RF gain connected. Someone has modified it. Don't understand what it is. This is R410 and C407. This resistor is not existing, and instead of this resistor we have the pot RF gain connected. This is a chain, IF chain, it comes from the RF unit. Amplifier, the gain of the amplifier is controlled via the S-meter or the AGC line. Amplifier, second amplifier, this is a fixed voltage. But here we have a variable resistor. Okay, this would vary the gain of the transistor. But I assume now that this input is open. And then we have here no voltage divider. So this input swings up to full voltage. So we have full voltage here, full S-meter deflection, and no output for the AGC line, and no reception. Who did this? In my brain there's running a counter. If I see another such stupid modification, then I think I will stop this project. Makes no sense. Anyone did this, anybody did this, and he didn't know what he is doing. Now I will check what's going on there. Here we have the pot, and here we have, I think we have nothing. The behavior of the instrument is a little bit weird, but we have this problem seen in the position PTT. There is possible to transmit, to receive, and in receive we have full deflection, as we have seen due to the modified RF gain. In this position we have manual transmit, MOX. That means we are in the transmit mode now. Okay, PTT works, but again we have here the problem as indicated. I'm just removing the screws from the bottom cover, and I see here's a switch. As this is the FM AM switch could be. I hope I can flip out this bottom cover, because I need access to the main board, to the contacts of the plugged PCBs. Here we have the switch. Okay, these tapes are very interesting. They are not good for electrical isolation, but that's not relevant in this case. Whatever it does, whatever it interrupts and switches on and off. Here we have an interesting bad workmanship. I show it. Not sure whether you can really see it. Here we have some fibers hanging in the air. The solder is bad. Some fibers are not isolated, they are not soldered, they are making contact to the parallel pin. Oh no, oh no, oh no. Another weird behavior I've detected here in the channel select VFO. Okay, we are on the 10 meter band. The VFO operates. When we go to the 11 meter band, sorry, to the 11 meter band, we have this indication, but when we go to a channel, we suddenly have 26, 5, 26, 25, 5, 25, 0, 24. Here we have 20. What is F? We can imagine. Or is nothing. Ah, here we have 27. Interesting. There are some crystals installed in the channel selector, but this is not a band switch. But I think someone has modified it to use it as a band switch for a wideband operation in the range of 28, 27, and so. This, I think, is an explanation for the weird behavior of the switch. I have 15 megahertz, 15 meter, sorry. Okay, this means VFO. RX external means that the RX, and we are in RX mode, should be external. VFO shouldn't be lit. When I go to transmit also. And TX extern, okay. That's okay. TX, we are in RX mode, VFO is indicated. When I go to TX, this disappears. That's okay. But in this case, RX extern, it should be vice versa. No reaction. This can also not be true. Completely messed. Completely messed. These frequency settings here indicate that someone has tried to modify it as a CB radio, also for lower frequencies. For 26.5, 26, and here we have 27 and 27.5. These are the known legal and illegal CB frequencies. In mode SSB, FM and okay, AM in those days maybe. But please don't do this. The result what we have, a totally messed and destroyed shortwave radio. It is not a CB radio, does not work obviously. Whatever the guy has done, it's not operating. Buy a CB radio if you want to do CB. It's cheaper. And if you want 100 watt illegal power, buy a power amplifier for 10 and 11 meter. It also should work. But do not abuse such a transceiver for this purpose. It's not a good idea. This is a quick end of this project. I do not waste any second in this transceiver. It is not worth. It would be a complete restoration project, not repair, restoration. Restoration means bring it back to the original state. And this would be a big project. The behavior of some switches is very strange. So there are many modifications in it, maybe errors or short circuits, I don't know, faulty components additionally. So it would be a hard work. And this transceiver isn't worth it. There are such transceivers on the market for 100, 200 euros, which are obviously working rather good. To bring this transceiver in a state which is working, it is not worth many hours and a lot of nerves. So I don't do it. I'm too old for this. No. I will tell it the owner. He can pick it up here at my home. And one personal note: if you ever do modifications on a transceiver, think about what you are doing. If you read an article in a newspaper, in any journal or in the net, do not do it as long as you really understand it, what you are doing. Don't start with a list what to do. Connect R1 to C7, disconnect the trace, solder a bridge from there to there, and change any value of a resistor or capacitor. You have to know what you are doing. Otherwise the result is a totally messed transceiver like this. It's a joke what we have here. Anyhow, stay healthy, stay tuned, see you on this channel. And the next project, which is under my workbench here, is a more interesting project than this one. Promised.